There we go. Okay, so this is actually the first day of physics. Everything we've done so far, before now, has been largely mathematics. Okay, so at this point we're actually starting physics. This is the first set of physical principles that we have. So let's go back and look, and don't write any of this down. Okay, let's go back and look at some very, very bad science. Okay, so this is pre-scientific method science, Aristotle, and Aristotle basically said that you could do science without doing an experiment. So you could observe things, and like, for example, he observed frogs coming out of the mud when the sun warmed it in the spring, and he said, if you take mud and you warm it, you will get frogs. Yes? And he wrote it in a book, and for a long, long time, if you wanted to know how frogs were made, you read the book that Aristotle wrote, and you accepted without question that frogs were spontaneously generated by mud, right? And so what Aristotle said about moving objects was just as wrong, okay? And he said a number of things, right? One of the things he said was that heavy objects fall faster than light objects, okay? So if I have one pen, right, and I have, in the other hand, two pens will fall twice as fast as one pen, yes? Okay?
No.
Okay, and so when this one is all the way at the ground, this one will be halfway down. Let's do an experiment. Let's try it again. It looks the same to me, right? And he did this with grapes in front of the Pope and got in trouble, and ultimately got in trouble with the Pope for insisting that the Earth moved and that orbited the sun and all this stuff, right? So this is a story that I'm not going to go into. Which one about the Earth moving?
No, the heavier objects.
Oh, the heavier objects. Grape, one grape and two grapes. Yeah, there it is.
Observe the wrong thing, though.
Well, it was the Pope didn't have an explanation for it, but what had happened was the Church had said, "Look, Aristotle is right," and so, yeah, not a lot of critical thinking there, right? So, but what's interesting is that the Church, and by what do I mean by the Church? The Catholic Church, right? Okay, and so. The Church has since, in fact, I think there was some bishop that said that the Bible tells us how to go to heaven, but not how the heavens go, which I think is sort of an interesting perspective. Yes? So the Catholic Church has gotten out of the business of trying to do science, but don't worry, other churches have stepped right in and are doing science. There we have it, right? Okay. But anyway, this is what Aristotle said about moving objects. Okay? He said that moving objects tend to sit still. Okay, please stop. Okay, so moving objects, here's an object. If I move it, it will move, but it'll only move for a short period of time. It will eventually stop because that's the inherent nature of objects is to sit still. Okay, and I could try this with a lot of objects, and it seems like Aristotle is right. I can take a stool, and I can push this stool, and this stool will move for a while, but then it will stop. Yes? Mm-hmm. Okay, now I think you guys could probably tell me why it's stopping. It's touching the ground and friction is slowing it down, which presumes, by the way, that without friction it would do what? It would keep going forever and ever. Now this is something that Galileo, okay, I'm sorry, I have to do that every time, right? That Galileo observed, and he did this following experiment. He took, I believe it was marble, he actually took marble. I wonder if marbles were made of marble originally, right? Marble is wonderfully soft. You can make it perfectly round with a simple machine that polishes it equally and moves it around like this, right? So you got these chunks of marble, made them perfectly round. He rolled them down an incline like this, and he would roll them, nobody else had done this, right? He rolled them up a plane of lesser incline. Okay, so he'd roll it down a steep plane across the level floor, and then it would go up a plane of lesser incline. And here's the rule he discovered, was that this thing would roll until when? It would roll until what? The same height, only a little bit less. And he figured out, he was smart enough to figure out that little bit less was because of friction, right? Yeah, roller coasters work on the same principle. There's a lot of friction with roller coasters, right? But yeah, it's the same sort of idea, right? And so what he said was, okay, look, if there never was an inclined plane here, and the table went on forever and ever and was frictionless, right? Okay, what would it do? Would it ever reach the same height? No, it never would. So therefore, would it ever stop? No, it wouldn't. Okay, so Galileo introduced this idea that objects have inertia. Okay, so I will write Galileo, and I will write inertia. Okay, inertia is a tendency to resist a change in motion, a change in motion. And by motion, it's like, what do we mean by motion? There's all kinds of motion. There's acceleration and displacement, all this stuff, right? Motion, by this we mean velocity. Okay? Okay, so we're talking about objects that are sitting still tend to want to sit still. Objects that are moving will tend to keep moving. Yeah? And they'll tend to keep moving in a straight line, yes? And they aren't going to go around corners spontaneously, et cetera, right? The inherent fundamental nature of objects is that they will just keep doing what they're doing. Okay? In short, what they're going to do is, and I'll see if I can get this on the little film, see how wide it gets. Does it get that wide? No, it doesn't get that wide. Somebody want to point it around here so I can see this air track, the camera? Connor, do you want to do that? Point the camera around so we can see this. There we go. Okay, this is an air track over here, and I've got an air track blower. Move the handle up there. There you go. All right. Okay, this is an air track blower, and kids are always asking me how I do my hair, because it's always perfect, isn't it? Pretty much when I come in here, right? There it is. This is how I get that kind of that outdoor wilderness model look, right? Okay, now children, what I'm going to do is I'm going to attach this hose to the end of the air track, and I hope, Laura, we're making a good impression on you here at Tualatin High School. How's it going at Tualatin? Are you enjoying your classes so far? Yeah. Good. All right. If I attach it to this end, then the air comes out through there's myriad holes in the surface of this aluminum track like that, and it lifts the air, it lifts the cart up so that it rides on a film of air. Okay, and essentially it reduces the friction force to nearly zero, and so the object will that is just never not funny. Okay. It's essentially, it's just going to go forever and ever. There it is. Yeah? It's an amazing thing. There it is. It just goes and it goes and it goes. That is the nature of objects, is that they will just tend to go. Okay, the only thing that will make them stop is... It's like air hockey. That is like stop. I'm stopping. Yes. Yeah, it's like an air hockey table. Yes. Love it. Okay, now, this is the most wonderful. If you could point that camera kind of toward the front now. There he is. Am I on there? Here I am. Point it just kind of over here at the wall. There we have it. Okay, can we see? Can I see myself?
There you are.
Am I on there?
Yeah.
I can't even see it. The monitor is so small. Okay. This is a funny story, right? So I go to, and this is a weird thing, right? Is that objects have this inertia. Big objects have more inertia. Small objects have less inertia. Yes? Okay. But this is a weird thing. Okay, this is one of the weirdest experiences in my life. Okay, I went to a backstage tour of the Guthrie Theater Company in St. Paul, Minnesota. No, Minneapolis, Minnesota. And it sounded like a real snoozer. My dad got these things. He was all excited about it. I'm like, ooh, this is going to be really fun. No. Oh, my gosh. They have on their stage sets, they've got these stage sets that weigh they are like 3 or 4 SUVs worth of weight sitting there on the stage. The stage is like laser leveled, and they float them on air. Yes? In my high school, sets would move on wheels, and they sounded like vaguely like siege engines moving in the dark. Yes? Squeaky, 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 squeaky. Yes. Okay. Stephen tends not to use wheels, does he? I don't know. Does anybody know? Seems like they don't. They use very minimalist sort of sets, right? Okay. Guthrie Theater Company has these enormous sets, and they're clever about them. Like they've got a thrust stage, and the set might have like 3 sets on it. They just have to rotate it, right? But sometimes they need to move it all the way off the stage. So they lift it up on these